Hello everyone. Let's start with some questions we can solve from like week 7. Oh, sorry, week 11. So again, I will repeat. We know that in the course of ESTC, our main focus is on the circuit analysis and all. But we know that after circuit analysis and all, where to use and what applications uh, normally use this kind of circuit in the back end and all. Due to that, we understood from the week 11 lectures that one application is that nowadays we are using communication as that in the wired communication or wireless communication. If we talk about wired communication or wireless communication, also, we use the device, whatever for this communication purpose. Those devices are dependent on the electric devices, and those devices deals with electric circuits, and those electric circuit analysis again are related to these ASTC codes. Is it clear? So just let me give you some brief idea. If we have some device here, I can say that a transmitter and one is receiver. From the transmitter, if you are sending some message signal, so that message signal will be like transmitted from transmitter to receiver through this path, and this path is nothing but known as channel, and this channel may be of two types. One is your wired channel, another one is the wireless channel. What does it mean by wired channel? Is by using some cable, fiber optic cables, or some like uh, physical cables will be connected between the transmitter and receiver. Then only that path or channel is known as your wired channel. When there is a transmitter, like we are using mobile devices, receiver, there is no channel physically present, but they can communicate through the wireless channel. How is it possible? So by using electromagnetic waves. Is it clear? Any doubt is here?
No, ma'am.
Okay. So by using this electromagnetic waves, we can communicate from transmitter to receiver. That is known as wireless communication. Okay. So if we means talk about like we have transmitter here, we have receiver here. So you can do multiple way of communication. For example, I have here M1, M2, M3 like this. A means like K number of messages. This K number of messages I need to transmit from transmitter end to the receiver end. How can I do it? I can go for multiple channels or same channel. If I'm taking the same channel, means single channel between this transmitter and receiver, then I have to fit this message one by one. First, message one will be transmitted. When message one will be received here, then message two will go to this. Then message two will be received like this. It will go on. This is known as serial communication. Okay, one by one message we can transmit. And how can we transmit? Based upon period. For example, I can take like T period some time, and if I take same period, then for each message may take same number of periods, like T maybe if I'm saying 1 second, so each message will take 1 second to transmit. In that way also we can also vary the period also. This is nothing but known as serial communication. Okay. So coming to the next kind of communication, we can, sorry, something I think delay. Yeah. Now the screen is visible, right?
Yes.
So for example, transmitter is here, receiver is here, and we are doing the wireless communication or wired communication also, no problem. I need to transmit multiple signals together. For example, like this one channel N1 is transmitted, another channel N2 is transmitted, like this in number. So if you want, if you are going for wired communication, then you have to send K message signal by using K cables or wires, right? So it is nothing but known as a parallel communication. Same time, you are able to send all this signal. Are you getting my point?
Yes, ma'am.
Okay. So based upon this concept, let's do some questions. Let me ask some questions from your means, activity questions only I can ask. So, for example, if I say uh, parallel communication, my question is that if I ask you what is the advantage of using parallel communication, can anyone tell me? If I give some option, like option A may be it require fewer words, it allows faster transmission of multiple messages. Third option is it is easier to implement. And fourth option is it reduces the cost of communication. Can anyone answer me so that I can just discuss about each and every point?
It allows for faster transmission
Okay,
of my.
okay. Anyone else?
Ma'am, all four, I think.
Okay. All four option is not there.
So, ma'am, if all four, then B will be the most
Really,
right.
answer. Okay. So if I talk about it requires fewer wares. That's correct. But we have to see that like which is the prominent answer. Because what is the majorly advantage of using parallel communication? Advantage of the parallel communication will be we have to see. In parallel communication, we are using the fewer wares, but this may not be advantage, but we are using, right? Are you following me?
Yes, ma'am.
And the third point is it is easier to implement.
No, ma'am, it will be wrong. I was wrong. It will be wrong.
Uh, it is easier to implement means if you're going for the parallel communications, implementation may not be that easier because multiple wares you have to install, right? then it may not be because it is for this we are using this, but it may not be advantage. It reduces the cost of communications. If your number of wires are increasing, how the cost will be reduced? Cost will be increasing. That means it may not be also, right?
Yes.
Then leftover is it allows for faster transmission. As I had shown here, like you are using t means t if it is 1 second. In 1 second, you are able to transmit k number of messages. But in case of serial communications, you are taking k seconds to send k number of messages. Am I right?
Yes,
Are
ma'am.
you following? Is it clear?
Yes,
So
ma'am.
let me ask another questions to you. So, question two, if I ask, what is the potential limitation? Means I'll not give the option. You have to tell me potential limitation of using parallel communication with many users. Definitely, parallel communication means many users. So, what will be the potential limitation? What is the major limitation in this? Already, some of the things I have discussed in the previous question. That's why I'm asking without giving the option.
And distortion or mixing.
In the previous case, whatever we have discussed, right? Mixing was not there. From those options, can you tell me what is the major limitations? Very
Ma'am,
good.
it is not easy to
More, more airs, more wares. Already, your friend has answered. Uh, so we are using more number of wares. This is the biggest limitation of this parallel communication. Got it?
yes.
So the options, if I say, if it is too slow, it requires too many wares, or other option may be here. One second, just a second. That's my list. Is the screen visible?
Yes, ma'am.
So I may say, tell you that like you are using too slow means definitely it is not slow. It is faster communication. It requires too many words. Yes, it is one of the biggest limitation. It is too complex. Yes, it is also too complex, but limitation is many words. Okay, and it is not secure. Can if someone is asking if you have transmitter here and receiver here, and if you're connecting through the wires, multiple wires may be also no problem. Single, if it is parallel communication, it's serial communication. If you have wired communication, so can you tell me, is it secure? Or if you have transmitter and receiver here and they are connected in wireless, so which is the secure communication?
Ma'am, wired is more secure.
Yes, why?
Ma'am, because there is a single medium and signal can't be easily distorted.
Single medium not means like we can say that This end to end has like protected through the wear, and this cannot be easily tampered by other signals, right?
Yes, ma'am, that's what I like. Single medium, and in the wireless, the signals can be distorted. Like it can be. Uh,
Other signals can be disturbing this because of wireless. This is not protected. Like for example, one example, simple example, if I give, for example, this is the transmitter, this is the receiver. Okay, so I just, as a layman, if I say, I have like a path like this. If you have seen our underground, if you see underground, people are walking like this. Simply, they can reach easily there. If this underground is not there on the road they are crossing, then there is the chance of accident because many other vehicles are coming, right?
yes, ma'am.
Okay, that way you can think that. So whenever underground you're going, other vehicles and all, nothing is there. Only your pathway is restricted for the walk. But here on the ground, if you are walking, then other vehicles are also there. Similarly, if you say word, in the word, the signal is protected inside because no other signal can means like enter to that shielded air. But in the wireless, if you are sending some message, other wireless, other signals may be there that may hamper, like I said, other vehicles will be there. Okay. So this way we can say that your wired communication is more secure in nature. Okay.
Okay, ma'am.
So if I ask you that what alternative method is suggested for sending multiple messages without using many webs? What will be the alternative method? Means if we are using multiple wires are used to send multiple messages, right? So, what are the other uh, methods are there? For example, option A, if I say option A is increasing the number of wares. Option B, I can say changing the time period of the messages. Option C, I may say using wireless communication. And option D, I may say sending messages one at a time. Which option will be correct as per this?
Sorry, then what's the question exactly?
Multiple wares, I have written here, multiple wares are used to send multiple messages. Okay. What alternative method to
You
reduce
know,
this?
yeah, we'll use the wireless.
Any other answer? Is it possible?
Yes, ma'am, wireless is. I think it's correct.
Okay, good.
Madam, option B.
Changing the time period of the messages. See, changing the time period of the messages will not be like reducing the multiple wares. Because multiple words whenever you are doing, then you are using the same time period, you are sending the multiple messages. If you are changing the period also, means how it fits to this. The major question was that if you are using multiple wires, then you are able to send the multiple messages, right? But how to reduce this multiple wires thing? If you are going for the wireless channel, then in the wireless channel, what can be happening? Your answer, whatever is there, we can send multiple time periods T1, T2, T3, T4. Your message 1, message 2, message 3, message 4 can be sent, but that can be also happen in the wireless. Like for example, if I say here, this is my T1, this is my T2, this is my T3. In the T1 period, the first message was transmitted wirelessly. T2, second message. Then T3, third message. But you are not using multiple wires. Whenever you are using wireless only, then you can do it. Whatever you are saying, this time period of changing the time period of the message, that is only possible whenever you are going for the wireless channel. If it is wired channel, then multiple wires will be there, obviously, right? But the question is that how to remove these multiple wires for sending the multiple messages. Is it clear? Is it clear? Can you answer? Is it clear or not?
Ma'am, clear. These people are sending ticks. Like, they're not answering.
Okay, so let me ask another question here. What is the time period? What is the time period? Slowly I'm entering inside. Okay, I just started with some theory, then entering to a little bit to analyze more in detail. What is the time period for sending one message at a frequency? I will come to that frequency, amplitude, and all. Frequency of 10 kilohertz. How can we find it out? For example, I have a message, some message is there, and this message signal I can represent with some bits like this. 10101. I'll come how it we are doing on all. Right now, I'm just telling. So this message I want to send from transmitter to receiver. So this message signal has the frequency of 10 kilohertz. Okay. What does it mean by frequency?
Ma'am, number of cycles
Cycles per
in a particular second, like per second.
unit time,
Yes,
right?
ma'am. Yes.
So if you have a frequency is 10 kilohertz if you are writing. So hertz means what? It is nothing but second universe, right?
Yes, ma'am. We can use the formula T is equal to 1 by F.
That means it is second inverse means 1 over second. That is nothing but 1 over time. That means F is equals to 1 over time, right?
Yes.
Right? So I can use F is equals to 1 over time means if I know the frequency, then I can find the time period. Frequency is given to you 10 kilohertz. Now question has asked you have to find out the time period. Can anyone find it out and tell me what is the time period?
Point
And
1 millisecond.
uh, okay, how are you getting it? 10 kilohertz. 10 kilohertz means what? 10 into 10 to the power 3
0.1
hertz.
millisecond.
Answers are varying. Now tell me, how can I find F equals to 1 over time? That means time is equals to 1 over frequency. I can write 1 over 10 to the power 4 hertz. Right?
Yes.
So this can be written as 10 to the power minus 4 second.
Yes, sir.
10 to the minus 4 second means I can write 10 to the power minus 3 into 10 to the power minus 1 second. And 10 to the power minus 1 is nothing but 0.1. 10 to the power minus 3 means millisecond. 0.1 millisecond I can write.
Yes, ma'am.
If I want to write in the microsecond, can anyone tell me how many microsecond? 0.1 millisecond? 0. If your option is in the microsecond, it is not in the millisecond. 0.1 millisecond will be how many microsecond? Can anyone
Madam,
100
madam,
microsecond.
point one will divided by 1000.
tell me the answer?
100 microsecond.
Point 0001 microsecond.
1
No,
millisecond.
sorry.
1 millisecond is equals to 1000 microsecond. Okay. Then 0.1 millisecond will be how many microsecond? Simple. 1 millisecond, 1000 microsecond. 0.1 millisecond will be how many microsecond?
100.
Pardon?
100 microsecond.
I'm not getting your voice.
Yes, ma'am. 100 microsecond.
Yes. Either way, you can take 1000 by 1 millisecond, multiply this, or otherwise you can see 0.1 is divided by 10 divided by 10, directly 100 microsecond. Right? Is there any doubt? If I say, and the question is that if each message, again, little bit enhancing the question, consists of 4 bits. Okay, how long will take to send 10 messages serially at 10 kilohertz? Try to understand the question and tell me the answer. You have one message whenever that one message consists 4 bits. Now you have 10 messages. That means 40 bits. Okay.
4
And
millisecond.
10 messages you have to send serially, one by one. M1, M2, M3, like this to M10. So how long it will take if you have 10 kilohertz is the frequency?
Four millisecond.
Is it correct? Anyone else can try? Can anyone try? Yeah, tell me how did you get the 4 millisecond? I will just write here.
So it says in series, so it's sequentially. So if
Yes.
the wires are connected sequentially, so we take it like
See,
number
where
of
is
bits
like
into T.
this is TX, this is RX, and you are sending the messages like M1, M2, M3, like this. Last message will be M10 will be sent. Serially, you're sending no? First M1, then M2, then M3, then M4, then M10. Right? Yeah. Tell me, how did you do it?
So the time period will be 4 times the T.
4 times?
1 by 10 kilohertz, which is 0.1 millisecond.
When we have got
Uh,
zero, sorry, and
can you continue? Someone, just one person complete.
no, ma'am, no, ma'am. I was saying that.
Yeah, tell
Confused.
me. No, no, why confused? You are answering, no? 4 millisecond, that is correct. Tell me how you have found it.
Actually, I was saying like got the answer. Last question. Do calculation here.
No, no, I'm asking 4 millisecond right now. Someone told the answer. I'm asking how did
Yeah,
you
ma'am.
get
4 into 0.1 millisecond. So for one message, it takes 0.4 millisecond.
no, no. How did you get directly? You should not say 4 messages you have definitely.
So
Then you
4
have to
bits into the time period.
see you have frequency 10 kilohertz, right? So each you have 10 messages M1 to M10, right? Then how? What is the process? Tell me so that I will write here. So others can also follow that.
Madam, first we will find the time period.
Ma'am,
So time period will be 1 millisecond, and total
How
message
how point directly don't tell me. Point one. What is the formula you say so that all can follow?
T is equal to 1 upon F. So 1 divided by 10,000
10 to the power 3. Okay. Then from here you
so
are getting 10 to the power minus 4 second. It will
second.
be 0.1 millisecond.
Yes, ma'am.
Right? Okay.
Yes.
This is the total time you got it. Okay. Next.
So total message is 40 bit.
Yeah,
ma'am,
40 bits.
I was saying like I have don't have the final answer, but it will be 40 bits. So it will be like it. We have caught the time period. Time period is the time taken for one frequency. So it will be like in one frequency we have 2 bits. Like, am I right, ma'am? In one frequency we have 2 bits up and down.
How did you know that?
No, actually, I was confused. Like it have two
No,
signals.
it has not given you. In the question, whatever the data is that from that you have to do. Whatever you are saying, the statement you are saying that one frequency, 2 bits. So this statement, is it satisfying from this content or not? You have to check. Anywhere is it satisfying that 2 bits is taking one frequency? Nowhere it is mentioned. How are you taking this statement?
Then
This is
I was saying like in a one cycle there is a positive cycle and negative cycle, positive half and negative half. That's why I was saying
okay.
it's just my assumption. I don't know whether I am right or not.
Okay, I'll come to one by one, but let's complete. Someone was telling me, let me complete according to him, right?
Yes, yes, ma'am. Yes, ma'am.
Yeah. Tell me. You got t is equals to 0.1 millisecond. Next is
Ma'am, for 1 bit it takes 0.1 milliseconds. For 40 bits it should take 4 milliseconds.
40 into 0.1, that means 4 millisecond. Okay, so now you are getting this t is equals to 0.1 millisecond because your frequency of the message signal is given you 10 kilohertz, and you are sending the 10 messages. So 10 messages with a 44 bits. So I don't know message how the message is there, right? But total message 1 contains 4 bits. How it contains, I don't have the information. Whatever you are saying, one frequency, 2 bits, that statement is not at all satisfying with this. Only we know that one message is having the 4 bits.
Ma'am, I did not say 2 bits. I say 1
Okay.
bit takes 0.1 millisecond.
No, not for you. Someone told me one frequency,
Yes,
2 bits.
I
Oh,
was
okay,
saying.
okay.
For him only I'm saying. So nowhere it is mentioned one frequency, 2 bits. Only it is mentioned message is each message is containing 4 bits. And we have 10 messages means 40 bits. And it has given the frequency is 10 kilohertz. As per the frequency, we are getting the time period is 0.1 millisecond. If 0.1 millisecond it takes for single message, then you have the single message is having the 4 bits, and 4 bits takes 0.1 millisecond. Then your 40 bits will take 40 into 0.1. Uh, uh, it's nothing but for 4 milliseconds.
Okay,
Is
ma'am.
it clear? So that depends upon your question, what it is given. Without going through the questions directly, we cannot say that. Okay. For example, if I say another question, I say if the frequency of oscillation is 50 hertz, what is the angular frequency? This is nothing but noted as omega in radians per second.
Ma'am, I think your screen is lagging. Like it's on
Breaking up.
it's on the previous question.
Screen is breaking up now.
Yes, ma'am.
Just a second, it will come. My tab and system has some lag.
Why don't you use a desktop app? Like there is a Microsoft whiteboard.
Yeah, Microsoft Whiteboard is there, but easy to use from tab to this. That's strange.
Okay, okay.
Previously I was using that only. It's easy to use here. Just a second. And now I think it has come, right?
Yes, ma'am. Now it's coming. Now it is.
It is little delayed, it will come. So you are look means getting the screen.
Ma'am, it's on the sixth question. Like sixth question is on the screen.
Yeah, the video is fine now.
PDF fine, but sixth question is on the screen. It means
Which is what we are doing right now.
What?
It's too delayed. Let me stop present and again present it. Just a minute. Just write the question, whatever I'm talking about that. I wanted to know that if the frequency of the oscillation is 50 hertz, 50 hertz is the means like frequency of oscillation is given. What is the angular frequency? That is nothing but omega in radians per second. Can you find it out and tell me? By that time, let me fix this issue. Are you trying?
Yes, sir. It will be 3314.16 100 into pi.
Have you converted to the radian? You have to convert it to the radian in your on your calci.
However, I don't have to put like 100 pi will come omega equal to 2 pi f.
Omega is equals to 2 pi f.
Then, ma'am, what you are saying, like I put the value of pi 3.1416,
Okay. Then answer is
314.16.
yeah, good. So all others got this same answer.
Yes, ma'am.
Okay, good. So do you have the understanding that what is this angular frequency and fundamental frequency? Do you have idea about the angular frequency and fundamental frequency?
Yes, ma'am, but not very much clear. Like and just like rate of change of angle displacement, like in which rate the angle is changing. Particularly, it is used in periodic or harmonic motions.
Angular frequency, like we usually have radians per second.
For fundamental frequency, we have like hertz.
That is see in simple okay form. Now you have right like substituted omega is equals to 2 pi f. So 2 pi means what? 360 degree. 2 pi is the 360 degree or not on the circle?
Yes, ma'am, 360 degrees.
360 degree. So you are just checking that on the circle that like what is the rate of change of this fundamental frequency, right? So that's why you are writing 2 pi f. 2 pi f will give you the angular frequency. So something happened to my tab. My tab is not connecting at all. So let me use otherwise the Microsoft.
You can't directly stream from tab, like joining from tab directly.
Yeah, I can also do that also. Okay, no problem. I think some like time got over also. Just I will give you some few other questions also. Can you just let me know some few questions also I'm asking. Can anyone tell me what is the typical range of the FM radio? Hello? Hello? Am I audible?
Yes, ma'am, you are audible.
Yeah, can anyone tell me what is the typical range of the FM radio?
No, no,
So